So, um, we're just going to finish up the gearbox we started on uh yesterday. Yeah, it was yesterday. So this is where you should be at right now, or somewhere around this point. Um, yeah. So let's just get straight into it. So we made this top hole for the Thunder Hex bearing, right? So you have to import the Thunder Hex bearing, and luckily it is in fact on MKCAD. So you click on MKCAD and then you search up Thunder Hex, and then the first drop down here says bearings. You click on this drop down, and then you'll see it says over here Thunder Hex inner diameter. ID stands for inner diameter. Thunder Hex inner diameter 1.125 inches outer diameter flanged bearing. You want this one. Okay, this is the one that we're going to be using for next season. Okay, so I would say to put a heart next to it. I'm going to show what the heart does. So you click on it and then it appears. And then what the heart does is if you don't have anything in the search bar, you can go into favorites and you'll be able to see your favorites. You can do this for the swerve as well. So I'm going to do that actually. I will heart the swerve. So SDS MK4I swerve module, make sure it's the configurable one. It Make sure it's not the simplified one. It should be the configurable one. So I'm gonna heart that as well. And then they should show up. Yay. Okay, cool. All right, so now we have a bearing, and I decided that we will put the flanges. So remember the flange, if you go from the side, this part that's kind of sticking out from the rest of the body, this is the flange. It stops the bearing from going through the plate. I decided that we'll put the flange on the outside of the plate instead. So how do you mount a bearing to the plate? Well, the flange stops the bearing from going through on this surface right here. So I'm going to select this surface. Okay. Don't press on any other edge, only press on this surface right here when mounting a or when fastening a flange bearing, this flange bearing to like a plate or well, basically anything at all. So one of my main conductors is going to be this face right here. And then we said flange on the outside, so I'm going to pivot and select this edge right here if my mouse works. There you go. Press check mark, and now you'll see a nice little flange thunder hex bearing sitting there. Okay. Um, Second thing to do is to get bearings because this is a gearbox, right? So how and where do you get bearings from? Sadly, MKCAD, let me check. Yeah, so MKCAD does not have a bunch of bearings from WCP. Um, but if you go onto WCP site, so I already have like preloaded, but go on WCP, go into belt chains and gears, and then press on 20DP hex gears, and then make sure you're in the aluminum ones. Wait, I know, I lied. I lied. Uh, yeah, no, fine. We'll start with this one. So, the aluminum, the hex board gear will be the top one, right? It's the 64 tooth one. So you scroll all the way down, make sure you're half inch X, but look, all you need to do is scroll down to the table, right? And you see these links. You can like copy this link. It doesn't matter for which gear. You don't have to scroll all the way down and get the 64th gear, 64 tooth gear, right? You can just click on any of these links and copy any of these links, right? I'm going to copy the link of this one, which isn't even the correct bore, right? So I'm going to copy link address. I'm going to go back to my document, press on insert, and if I go to other documents and I press the home button and I paste the copied URL into the search bar, enter, I should see aluminum hexport gears. And then I don't really want to scroll down and find my specific gear. That kind of takes a bit of time. So you can utilize the next search bar, the search bar studio, and we know 64 tooth, right? So we do 64 and then T, and it's this one. And if we hover over it, we can check if it's the correct gear. So it says 64 tooth luminous per gear, 20 the diametral pitch is 20, and a half inch X bore. Half inch X bore, make sure it's a half inch X bore, guys. We're not using a 3/8 X bore gear. Okay, so I then press on this one, and then I press check mark. Okay, we now need the gear for the Kraken. So I have to do the same thing. I can go on WCP, hover over belts, chains, and gears, go into 20 DP motor gears, and scroll down. We decided on a 12 tooth, right? So I scroll all the way down to this table, copy any of the links here. So copy link address, go back to my document. This is not my document. That's my document. Go back to this document, insert, and I press the home, copy and paste my URL into the search bar, press enter, then 20 dB motor gears. Here with 12 teeth, you want to be careful because there are two types of spline access bore gears. Remember, for this next season, gears will either have a half-inch X bore or a spline excess bore. Spline excess bore is this shaft right here, or spline excess is this shaft that's on the Kraken. Okay, so we're looking for a 12-tooth spline excess gear. And there you go. I found 12 tooth spur steel spur gear with an 8 millimeter spine axis bore. But if we go up here, we'll see a 20 dimensional pitch, 14 tooth center distance, 8 millimeter spine axis bore. You want to choose this one that does not have the 14 tooth center distance. So click on that one. It's going to insert, press check mark. Cool. Well, now what? We have to start assembling it, right? Yeah. But we are not going to simply connect this face. So the hub, this called this like extrusion right here, like this little shoulder is called the hub. We're not going to simply connect the hub to this face of the bearing because we want to include an 1/8 inch spacer in between the two. So you can make your own 1/8 inch spacer, but there are also 1/8 inch spacers already in MKCAD. So if you go here and you into the search bar, you press spacer and you do spacer plus hubs, you will see a 1/8 inch, half-inch X, whatever that says, spacer. And there it is, right? Yes, it's a Rev product, but WCP and Rev probably most likely have the same spacers. Let me check what they do. Yeah, WCPs also have a 0.75 inch diameter, so we're fine there. So 1/8 inch spacer, import it, and yeah, now we have a spacer. Cool, we decided to mount it in between this shaft and the bearing. So I want to select the surfaces that are going to come in contact. I know that this flat part is going to come in contact with this face right here of the Thunderhex bearing, right? You can choose either this face or this face. And the reason why it's this face, not the interface, is because this face comes, I guess, first in order, right? It's the most like outside thing of the bearing. So I make a fastened, keybind is M. I press on this edge right here of the spacer, and then I go over here and press this face. You can press the edges, but faces for bearings are easier to kind of like they're I mean I like using here I'll rephrase that. I like using the faces. You can also use the edges, right? But I'm gonna click on the face. They both do the same thing basically. Check mark and beautiful. Cool. Also, if you don't have your gearbox fixed right now, make sure you do that. So notice how if I right now I'm gonna click and I'm gonna try to drag the gearbox, it does not happen. For you, it probably does happen. So make sure to fix the gearbox panel. You right click on this panel and then you press fix right here. Mine says unfixed because I already fixed it. Okay, beautiful. Um, then now we know next in order, we are going to have the gear, the 64 tooth gear. So same thing here. I want to mate the two faces that are coming in contact with each other, right? In real life, it will not be, for example, this edge and this edge. And how do you know if you did it wrong? Because if I hide this panel, um, on-shape magic, everybody, okay? No on-shape magic. If there's on-shape magic, that means that you did not follow real life. You did not follow life or physics or both, I guess. Yeah. So you select on this, you can select, I would select on the edge I like the edge here. But you can also select this face and press Shift while selecting that face and press, see that little like black circle, black and white, like a circle with like kind of a black top left, black bottom right, and then white top right, white bottom left. You can press on that one. I like doing the edges. They're easier, right? So I select this edge, and then I select the thing it comes in contact with, which is going to be this edge of the bearing, right? So you should, then if I press a check mark, it should look something like this. Now you're probably wondering, why aren't we making the shaft first? Well, that's because the length of the shaft depends on how long your, or I guess how wide your total gearbox is, right? It's, I like doing the shafts last because it's then easier. I'll show you guys why, but if you guys remember, extrude has like an up to face feature. You can use the same up to face feature with the shaft. Give it like 10 minutes, we'll get there. Okay, so there's the 64 tooth one. Now we need to mount the 12 tooth one onto the motor. Let me fix something. You don't do this. I just kind of, here, we'll put that to 0. This is already 0. You don't need to do this. So don't worry about what I just did with fasten 1. Okay, so back to this guy. We want to mount the gear, this 12 tooth gear, onto the motor shaft, the spline XS. So want to select the center of this gear as one of my make connectors, right? Okay, so you think, okay, well, I'm gonna try one of the edges. Oh shoot, right? And then you see a bunch of these make connectors. If you try to go to the center, it's not gonna end well. So what I like to do for these types of gears where the hub isn't a circle or where there isn't like a circular edge, you will have to do the um you can either do the shift, so you hover over this face and then you do shift and then you select the mate right there. Or what I like to do, or well, I don't know if I like to do I like to do both methods. Another method is if you zoom into this face and like you go further in, you'll see that eventually, once you start hovering over it without pressing shift, your mate connector, the golden circle, shifts to like the center of the gear. So I'm gonna do that, right? I zoomed in and now I click on this face, and then so you can see the white mate connector there, signifying that I've selected the center of this gear. Okay, cool. Well then, how do I mate it to, well, the spline XS? Well, if you noticed, if I go to the right view, the 12 tooth gear is wider than the 64 tooth gear. So I don't have to be like inch perfect in terms of where my contact is, right? I can make this 64 tooth gear have contact only like on half of this 12 tooth gear, right? Or I can make it maybe on like somewhere over here. It doesn't have to be perfectly centered. So what we're going to do right now is we're going to make the center of this 12 tooth gear to the edge of the panel. The reason why we don't do it all the way onto this edge of the Kraken, because if I select this edge, you will notice that, never mind, you won't notice anything. Um, we actually do have the tolerance to put in a gear into this 0.76 hole we made. So yeah, let's do that actually. So what I did here, I'm gonna redo that, right? I selected this face of the 12th tooth, right? I zoomed all the way in, make sure that it's in the center. And what I'm just gonna do is I'm going to select the next face where it comes in contact. So the next face that stops this gear from going, basically phasing into the motor, which is this face right here, right? It easily slides onto the spline Excel and then it gets stopped right here. So I can do the same strategy here where I just zoom in into this face. Or what I'm going to do, since there is a circular edge right here, I'm just going to select that circular edge and it automatically does a center for me. I press the check mark and there you go. Now you can see that your gear is not coming in contact with the panel. And if you are still skeptical of the gear kind of rubbing onto the panel, or you just want a bit more clearance, we can easily fix that. If you go back into your part studio and you go into your motor sketch, don't worry about the editing context. You go into your motor sketch where you created the hole for the motor. You can change this to be like, I don't know, 0.7, 0.78. Up to you. I'm actually gonna do 0.77. 0.77 is a good number to me. And then it should automatically update. And now you should see that you have a bit more space between the teeth of the gear and the edge of this hole right here. So yeah, cool. Now, if you notice, as I was saying before, this gear, it's not perfect, right? It's not perfectly centered, which is fine. We just have to make sure that this 64 tooth gear is getting contact, is fully getting contact by the 12 tooth. What we don't want to do, for example, is we don't do this by the way, I'm just demonstrating. 0.5, negative point 4, negative point 0.3. We don't want something like this. We want the 64 tooth gear, so the smaller width gear, to be fully getting contact. See how over here there's a space where it's not getting contact at all? We don't want that. We want to utilize as much contact as we can. So that is why all we really need to make sure for if we have a wider gear and a less wider gear, a gear with less width, is to make sure that the gear with less width is getting the full contact it can, is getting as much contact it can from the wider gear. Okay, cool. So we made our gears and our gear connections. Now, if you go into how these two connect to each other, you'll see that they are looking pretty good, right? So the we did our layout sketch correctly because the teeth of the 12 tooth gear are not phasing into the teeth of the 60 or like is not phasing into the body. So past like I would say this point into the 64 tooth gear, which is great. Okay, cool. Um, Now we are missing a panel, right? We want to have a panel on the other side. Now your instinct might kick in and you'd be like, okay, cool, we can just copy and paste this panel. Um, well, not really, because if you select that edge to this edge, you'll see that your spine access shaft goes through. Nice. So this would work, but we are not using we are literally not using this material at all. So we can just make a new panel that kind of cuts it off right about here, or right around here. So it'll just maybe be a half of this. And this is where edit in context comes to play. So let me quickly delete the edit in context that I made before. I'm not gonna do that. So now what you're going to do is you're going to make an edit in context of this panel. So you right click on this panel, scroll down and find edit in context. But then I already made a new context, but make a new context. I'm going to create a new context. And then you should see something like this. Now, when you make a new context, do not switch back to your assembly because if I switch back right now and I go back to my part studio, you'll notice that my context disappears, which is no bueno. This is my old context. So the context that I was trying to make, the new context that I was trying to make disappeared. That's because you actually have to first use the context in order for the context to be saved in this part studio. What I mean by used is like to make a sketch on it, right? So I'm gonna make a new context again. There you go. Cool. So what we now want now you'll see like your whole assembly being displayed in like a faint color, like or like kind of transparently-ish in your part studio because it's editing context. We will make a panel that is sitting, so see this hub right here? That it's going to sit right on the edge of this hub right here. So I'm going to create a new sketch on like this face. If I go back to my, here, I'll show more clearly on this face right here, because that is where our panel is sitting. Um, a good practice is to try to make your sketch as close as possible to the assembly. So for example, if we go into our prototyping bot and we go into the prototype master, right? This is how a robot looks like. But then if we go to our superstructure part studio, um, if it loads, please load. Okay, there you go. Go to our superstructure part studio, you'll see that this does not really resemble a robot. But these two gussets do. These two gussets in terms of assembly are in the correct spot, as well as these two, because if you go back to the prototype master, where did my box tubes go, man? There they are. You'll see that here we talked about this one and we talked about this one, right? And then compare it with the superstructure one, right? They're about the same. Same over here. We have the eye gusset here. We go into the master, we have the eye gusset there. So just a nice practice to have. Anyway, back to our gearbox. Rename your sketch, make it something that makes sense. I will on purpose not name mine, so you guys will have to brainstorm naming. Um, yeah, hardest part of design, I know, creating names. Once you create a name, we now are going to make the panel. Um, so this is where project, if you guys remember project comes in handy because we don't want to make our panel look something, for example, like this, right? Because if we make another quarter-inch panel that goes on the other side of the gearbox looking something like this, if we go from this view, we'll see that it doesn't line up with the back panel, which is like kind of like weird, right? We kind of want it, we want it to line up, is the point I'm trying to say. And instead of like redrawing every single line from scratch, right? If I want to make this line, I'll be like, okay, I'll make a coincident, or like, oh, I got to make these points. No, don't do that. Use project. So what we're going to project is we're going to project this line, this fillet, and then you would probably want to project this line, but don't. The reason being is because we are not going to, wait, hold up. Wait, no, I lied. Yeah, project these lines as well. Cool. Now we are going to use the arc tool and well, at least how I'm going to make my profile here is I will make it an arc kind of shaped downwards. So probably something like this, and I'll also make a tangent. If you take a look at you'll be able to see like the outlines of your layout sketch that you made right here. Or if you unhide it, you'll be able to see like the outer diameter of the 64 tooth. I will tangent that arc to the 64 tooth. You guys can make another outline over here. Like for example, if you want to make your arc curve upward instead, go for it. If you want to make a straight line, you can also go for it. But I'll make my kind of curved upwards like this. Reason being is I just kind of want to use less material. Um, yeah. All right. And sketch, dude, I'm fighting the urge to rename this, but then you guys are probably going to copy my name. So I'm not going to rename it. Cry about it. I was just kidding. Don't cry about it. Okay. Then something's missing here. You guys probably are saying, please, please be saying fillet like 1,000 times in your mind right now. We have to fillet these corners. We can do this. Yeah, we can do it right now. So remember Shift F and you press this and that. I'll put my radius at 0.2. I like 0.2 for some reason for gearboxes. You can use another radius, and I'll fillet that corner as well. Beautiful. And now we will extrude it. Make sure it's quarter inch. Press check mark. Wait. Oh, wait, hold up. Something's missing, right? Well, I kind of did miss this on purpose, but we missed the spacer holes and the actual hole for the shaft to go through because a shaft cannot go through a solid piece of aluminum, guys. I'm sorry. It's just not how physics works. So, how do we make those holes and the big hole right here? Well, again, you might say, okay, make another circle over here, make another circle over here. We don't need that. Project exists. You can project this hole, and as well as this spacer hole and this spacer hole onto your sketch. And also don't forget about the bearing hole. Bearing hole might be a bit hard to project unless you can hide your context and then go back into your sketch, press project again, and select on the hole. Cool. Then make sure your context appears again. Also rename your context. So you click on these three dots rename. Again, I'm not going to rename mine because I want you to rename them with something that makes sense. More practice for naming for you guys. Okay, then once you check mark your sketch, now your other panel should look something like this. Cool. Next steps are to rename the part. Again, I'm not going to do it. And edit appearance and assign material. Material 6061. Appearance, I usually go for this one. I like that color for 6061. Then I also assign material and I will go 60, 60, also 60, 61. Okay, great. We have the panel, guys. Quarter inch 60, 61. It's looking solid. Now let's assemble it. Let's go current document and part 3. It should be named for you guys. If you haven't named it, do that now, or I will force you to do whiteboard CAD next Monday. I'm not joking about that. I will literally check each and every single one of your dogs to make sure you've named that. And then you press what? Okay, wait, hold on. I kind of went ahead. So you want to attach this panel to this gear, and well, actually, even before that, we don't have a bearing in this panel. So press on literally any part of this bearing. I'm just going to press on this random line. Command C, Command V. And then what you can do is you can turn this around 180 degrees. And then what you do is I flipped it 180 degrees because if I do not flip it 180 degrees, what's going to happen is Onshape is just automatically going to assume that I want my bearing to be phased into this. Um, as you can see, my flange is literally inside of my panel, which is why you can also like go into the panel, the fasten panel here, and press flip primary axis. For some reason, I like to flip my bearings around 180 degrees, so like that. It's just a habit that I picked up and I like doing it. It's up to you guys for whichever method you want to use, whichever works for you. And remember the faces we select, right? We select this face and that face, right? The two faces that come in contact. So fasten mate, we select this face, then this edge, bada bing, bada boom. We've got another panel with a bearing. Beautiful. Great. Now, do we make the shaft? No, not yet, because we want to make sure that this panel is on the gearbox. Okay. Our shaft is not going to go up at a whatever angle that is, 30-degree angle. Um, I'm getting flashbacks from physics right now because they give us problems that are like force at an angle of 33 degrees on an inclined slope. Um, yeah, Kalashmi here are gonna get like absolutely PTSD right now. Anyway, so now you will select the two faces that come in contact with between the bearing and between the gear. So, also we don't need a spacer for this one, because so the reason I put the spacer here is just to give a bit of clearance for this 12 tooth gear, just to make sure the 64 tooth gear kind of pushes further outside. Also, it gives us a bit more room to work with these screw holes over here. Because remember, we want bolts going into the Kraken as well. So we're probably going to use this hole and this hole, so it gives us a bit more clearance for those bolt heads. You'll see what I mean later. So back to the fastened, I select this face of the bearing. I select this face of the 64 tooth, or the edge of the 64 tooth, press check mark. Now you should have a gearbox that looks something like this. Oof, I made a big problema. Currently my panel is doing on-cheap magic with the 12-toothed gear. So I will quickly fix that extra right now. You guys can spectate. So I will go into the sketch created this, and instead of making it tangent, I delete that tangent mate. I will make sure that it's cleared from the outer diameter of the 12 tooth. So I'll give it like a clearance of 0.2. and check mark. Now, if I change that dimension, you'll be able to notice that the panel changes in my gearbox as well. Now I don't have on-chip magic occurring, and my gearbox, nothing's mad at me, which is cool. Okay, so now we can start making the shaft. So let's just say that we'll make the shaft be short on this side and be longer on this side because we'll assume that we want to mount something on the shaft over here. So hence we don't want to have like an 1/8 inch long shaft on this side because we will not be able to mount anything on that. Let's do that. Go back into your part studio, make sure that the context you created exists. I'm actually going to rename it context because this is annoying me. Gearbox context. You know what? Collage. Um, yeah. Um, Now make sure to update your context. The reason why you want to update your context after you've made any changes in assembly is because your context is based off of your assembly. So if you don't update your context, what's going to happen is your context will quite literally be old, right? It'll be an old context with like an older version of your assembly. So when you use features off of the old context for sketches, for example, like projections, then you update the context, Onshape will get really, really, really mad at you because the parts you're projecting off of quite literally don't exist, or you've just altered them or changed them in a way. You'll get to have a lot of experience with that problem as well. So, okay. Shaft time. So we use a 1/2 inch thunder hex, and please do not make a sketch of quite literally a thunder hex. There is a feature script, and you guys should have it. If you go to your feature script dropdown, I'm going to do this. If you go to your feature script dropdown, you should see something called shaft generator. So you press on shaft generator, and here is the panel that should pop up. So shaft type. If you click on that drop down, you'll see 1/2 inch hex, 3/8 hex, thunder hex, 3/8 thunder hex, churro light. All the two you need to be worried about is thunder hex and 3/8 thunder hex. Yes, I know it does not say 1/2 inch in front of here, but trust me, this is 1/2 inch thunder hex. Okay, we're gonna be using 1/2 inch thunder hex this selection a lot more than a 3/8 one. So make sure thunder hex is selected. Retention type is not going to be shaft collar, it's going to be a bolt and washer. I will show you what that is later in the video. And then over here make sure this is not checked, by the way. And then over here, if we go onto this drop down, this is basically the type of extrude you want to make. There's either the blind one where you just input a length, or there's the up to face one. This is why I said earlier that up to face is going to be really, really useful here. So and then there's your end offset and offset. You guys will see what that does later. Then custom name, which you'll use in like 30 seconds. So origin, this is basically the edge of like kind of the edge of where your shaft starts. So for our example, our shaft will start from this edge, right? We want to cover the whole bearing. So this edge of the bearing, and we'll go, let's just say it goes 2 inches away from this edge of the other bearing. So it should look something like this with my mouse. It should be like meow, something like that, right? So boom. Let's go back here. I will select origin. I will select this edge, right? It's kind of hard to see in in context, but here will light mode be better? Light mode does not really, yeah. Actually, no, not really. I probably just flashbang you guys like 3 times in a row, so eh. Anyway, origin is going to be edge. End face is end face is going to be the edge of the other bearing we talked about, right? But you're gonna be like, hold on. I thought we wanted to make our shaft longer on this side. Yes, we did. So we can use end offset for that. If you start changing values in the end offset, let's say 2 inches, you'll notice that your shaft gets longer by 2 inches, right? That's the end offset. So end offset is kind of how longer you want to make your shaft at, like, for example, the end face or the origin. But we also want to offset our origin by an eighth of an inch. Reason being is because we're going to mount another eighth inch spacer over here. And we do this for the bolt and washer retention type, and also just for clearance for manufacturing. Because they probably won't be able to make whatever this shaft length is perfectly. So we just give them another eighth inch of clearance, right? Okay, so eighth inch offset, 2 inch offset, and then custom name. I will let you guys decide. If you, for example, write down uh physics and press enter, you'll notice that your feature script name turns to physics and also your part turns to physics. So, but please don't make it physics. Make it something that makes sense. I will not name mine again because I'm gonna call it like Shaft 3, which is a bad name. I'm gonna call it Calc. Yeah, that's what I thought. Short for calculus. Or wait, no. Hold up. No, short for calculator. I'm smart. Okay, press check mark. So now you have a shaft. Cool. But we now want to make spacers between these holes. So there are two types of spacers. Let me go back to this. There is this hex spacer, which if I isolate, you'll just see it has a hex like hub, right? So this goes onto a thunder hex shaft or a hex shaft. We'll be using thunder hex, remember? So hex or thunder hex shaft. But there is also a round spacer, and we need to make that round spacer. How to make that? Please, again, do not make a sketch. There is another feature script called spacer. I will quickly show you how to make a hex spacer and how to make a round spacer. So in this panel, you'll see this drop-down spacer type. There is round, half-inch hex, 3-inch hex. Don't worry about the 3-inch hex one. We're going to be using half-inch hex and round only. We'll be using them evenly, I'm going to say. Internal adder, external adder. For round spacers and the half-inch hex spacers, internal adder is always going to be 0.07 inches. Why 0.07 inches? Don't ask me. I told you guys last year we had problems with 3D printing our own spacers because they were too tight on our shafts. This is the number that worked, so we're just gonna keep using it. So for half inch, it's going to be 0.07 inch internal adder. And for external diameter for half inch, it's for a half-inch hex spacer, it's going to be 0.75. So these are going to be the constant values for, this is going to be the constant value for a half-inch hex and a rounded spacer, while this is going to be the constant value for a half-inch hex spacer. Okay, cool. Let's just say, so then it says same thing here, up to face or blind. Let's say I want to do an up to face and pretend this is a half-inch hex shaft going through here. So I say origin is here, and I say origin is there. Wait, hold up. What happened? Wait. End face there, origin is there. There you go. Now if I press check mark and then I isolate this part, you'll see that we've created a half-inch hex spacer. Um, but let's just for funsies check the distance on check how long that is. Oof, 0.623. So what we had a problem with last year is making, this is kind of my fault, but we don't talk about it. But I made a bunch of, or we made a bunch of spacers that had really weird numbers on them. It was even weirder than this. It was something like 0.14765 40, I don't know, phone numbers, but it was literally a phone number. I'm not even gonna lie. We don't want that. So we can buy, here, let me rephrase that. Spacers usually come in, well, they come in kind of nice lengths. What I mean by that is the smallest one is a 16th inch long spacer. So if I go to here, you'll be able to, I'll change this to blind. It goes from 16th inch, 16th, this is how 16th looks like on the side view. And then it goes to eighth, oh, eighth, and then it goes to quarter, and then half, and then 1, 1.5, 2, right? And we have a whole box of these types of spacers. We have a section in the box dedicated to 16th inch spacers, a section to 8th inch, some inch, that type of stuff. So we want to be using as many nice number spacers as possible, and we can also stack spacers. So for example, if I want to, I can make a 16th inch hex spacer, and then on top of that, I can make another hex spacer that is, for example, maybe an 8th inch long or 8th inch long spacer. Yeah. Um, so something like this, right? We can stack those nice spacers and basically get as close as possible to the our goal, to our value, right? And again, you'll have plenty practice with spacers later on. Okay, so if you follow me, delete this spacer and go back to this one. And now we're going to talk about rounded. Rounded spacer, instead of the hex hub, they have a circular hub. Same internal adder we talked about, 0.07, but external diameter is going to be 3/8. Okay, cool. And make sure it's up to face. And I'm gonna redo this. Origin will be this hole right here, or and okay, hold up, hold up. Yeah, yeah, why not? We can do end face over here and origin on the other side. You might get an error right now because what you did is you selected your end face to be this face right here, and you selected your origin to be on the same plane. And basically what you just did is you made a 0 inch spacer, which does not exist. So be careful of that. So I'm going to do origin here and face right here. And then it should have created this nice little spacer for me. Again, custom name, make it a nice name, please. I'm gonna name mine a not nice name, for example, the not nice name. I'm gonna F equals MA. Sorry guys, I had a physics test today, so I still have like PTSD from it. So I'm gonna enter that and cool. Then press check mark. Nice. Now we have a spacer. Now, please don't go and make multiple spacer feature script for each spacer, right? What I mean by that is like these pair of holes is one spacer, these pair of holes is another spacer, and then there's one, two, right? There's four spacers in total. You do not need to make four feature scripts because these are the same length spacers, so you can use the same ones and not waste your time on making uh three more feature scripts. Hint, hint. Is that like thing you do? Hint, hint. Is it hint? I don't know. Anyway, I did the feature script way multiple times, so I'm telling you guys not to do that. Please. It's gonna save you time. Okay, cool. So also the reason why we are not making the eighth inch spacer, like the reason why we did not create, for example, this eighth inch spacer is because importing from MKCAD is faster than making your own spacer. So we might as well just import. Well, also MKCAD has like, for example, it has 16th inch spacers. It has like basically all the nice numbers I was talking about, right? So keep that in mind. Okay, so is this everything? Yes, this is everything. Then make sure to change the appearance of your shaft and change the color. I will change my color to this to like it's 77. The shafts are usually like a dark color. I like using this one for 775. So shafts are 75, edit material. Oh, it's already 775. Cool. Then the spacers for the F equals MA spacer, or like AKA the rounded spacer, I will make it PLA. Because we can print our own spacers as well. So I'll do that and I will edit material. If you make yours PLA, if you type in PLA here, you'll probably get a bit confused because it doesn't pop up. You're gonna have to like scroll down a bit and find it in the dropdown and press check mark. And then for part 3 for this panel, I'm gonna rename it to Newton. Um, Make sure you also wait, did we already do this? Oh, we did. Okay, beautiful. All right, yeah. So that's basically everything you had to change the material and color of, and the shaft. Okay, now we can insert the rounded spacer you created and the shaft as well. So I click on you. Nice. And why is my shaft not appearing? What's wrong with my shaft? It's F equals MA. Come on, man. Not cool. Uncool. Where's my shaft? F equals MA. Oh, wait, no, there it is. I'm blind. Okay. Nice. Now go ahead and fasten those spacers. I'm going to show you how to do one. Remember fastening the two phases that connect to like that come in contact. So for spacers, I know it's going to be something like this and to this circle right here, to the center circle, check mark. And all you basically do is you do the same thing for this spacer for the rest of the holes. So you need to do this hole, uh, this hole. Then you make sure you don't do this hole, by the way. Then you do this hole and this hole. So three more fastens. Go for it. Okay. Now after you've mounted all your spacers, you should have something like this. Now, let's check how close our gear gets to our spacers. Oof, a bit close. Well, I mean, not too close, right? But another good practice that would have been for us to do is to go into the layout sketch where we created the holes for the spacers. So it's going to be right here. And we could have just in a construction line made the outer diameter for the spacer, which is 3/8, and just did this for each hole. That way we will be sure that our gears don't come in contact with our spacers. You can, I'm actually going to do that. So go ahead and do that right now. Just add the outer diameter for each spacer. Then while we're here, you should have noticed that we've actually created another spacer hole right here. If you go back into our assembly, you'll notice that we do not use that spacer hole because there is quite literally no panel we can connect a spacer to there, right? It's just air, which is why we don't need it. This was an oversight, um, because we didn't really think it through and well, and just kind of, let me see how to phrase this. Yeah, we didn't think it through and didn't realize that we didn't have to we shouldn't have like did this, right? We were assuming that this panel would be the same as this panel, but we didn't need all this material down here. So we created a separate panel, but since this hole was based off of the Command C, Command V of the same panel, we don't use it basically. So what you can do right now is you can literally just delete it or leave a construction. I'm gonna make a construction. Honestly, I don't know why. I'll just I guess construction for fun. Scratch that. I'm gonna delete it. We don't need it anymore. Okay. So now you should also if you update your context, it's going to look like it has all of the why is this thing here? Now if you update the context, you'll see the spacers appear in your context as well. Cool. Now you have to mount the shaft. Um, shaft is a bit kind of it sometimes gets a bit tricky, but right now it shouldn't be too bad. So remember how we said it's offset on this side by 1/8 of an inch? We're just going to use the offset feature right here. So the offset dropdown. And let's first though mount it to the bearing. So what I do here is I select this face, right, the outermost face of the shaft, and I know that we're offsetting it 0.8 inches from this edge right here, that way, right? So I mount it to this edge, right? I'm going to check it for now to explain some stuff. So want to make sure that it's in line with this face. Now, how I add an 1/8 inch to it is I can just use the offset tool. And how I know it's the z-axis is because if you zoom in, you'll see z, y, and x. Z is pointing in the direction I want to offset it, right? I don't want to offset it in x because if I offset it in x, it's going to start facing through stuff, right? So I will go into z and I'll put an 1/8 of an inch and it goes out this way by 1/8 of an inch. What might happen to you is that when you put in positive 1/8 of an inch, it's going to, the shaft is kind of going to do this. It's going to go into the gearbox. For you, you're going to have to put in negative 1/8 of an inch, right? But for me, I put positive 1/8 of an inch and it worked. So let's have this plus check mark. Nice. I don't know, don't worry about the nut. Then we said that we are going to have a spacer over here, right? An 1/8 inch spacer. Well, guess what? We already have an 1/8 inch spacer in our assembly, so we can just Command C, Command V, and mount it. So we press this face, or I press that edge, and I know that that edge is going to be touching this edge of the uh, bearing, right? Check mark. Cool. Now you should have something that looks like this. So what do I mean by the retention? So we talked about the retention of the shaft. What do I mean by a bolt and washer? Well, it's how we make sure that the shaft does not go left or right. Because currently the shaft, let me fix, don't do this, please. I'm gonna do this for demonstration purposes. Uh, do that. I'm gonna do cylinder, I think. Okay, yeah. So currently our shaft, there's nothing stopping our shaft from just going like this. Or please work. Please. Oh, there you go. There's nothing stopping our shaft from going like this, just straight out of it, right? Or we're going through this way. That's because we use if I turn it back to a fastener, we use a bolt and washer in uh in here. So we put a bolt and a washer onto this face, which stops it from going further back down that way. Let me insert a bolt. You guys can follow me along to do this, along as well. This is how you insert a bolt into your assembly. So if you go to ANSI inch, you go to bolt and screws, socket head screws, button head, and 1032, and then size is like the length of it. I'm going to do 0.5. Then you press on this hole, press insert, and a screw should appear in it, right? But we forgot about the washer, so I lied. Don't, I lied about the washer. We need the washer first, so bolt and screws, washers, and we're going to do this, insert, there's our washer. And then now what we're going to do is the screw is going to go on, or the bolt is going to go on top of that washer. So I select this face, insert, there you go. So that is a bolt and washer retention. The thunder hex will be threaded, tapped over here. Tapping, if you guys don't know, is basically how we create threads. Um, so this face will be threaded probably about like maybe an inch or so down. So we'll be able to put a bolt and washer here that stops the shaft from going all the way through. The reason why it stops is because if you look at this spacer cannot physically go through the bearing, right? The bearing is stopping it, the spacer from going through. So if we make this washer um, cover like the bore of the hex bore of the spacer, and we threaden a screw into the thunder hex and make sure the screw doesn't go through the washer, then the hex shaft will not be able to move out that way. But we cannot use the same retention type over here, because if we do put a bolt and a washer on this side, that's not what I tried to copy and paste. If we do put a bolt and washer on, oop, wrong thing. I'm kind of selling right now, guys. Give me a second. There you go. If we do put a bolt and washer retention right here, you'll notice that it literally does not come in contact with the bearing at all, right? Even if we put an 1/8 inch spacer here, like this, it does not, the shaft will be able to slide this whole length until it reaches this washer, which is not good. We want to make sure our shafts do not slide. So what do we do then? Well, there is something called shaft collars, which are basically a kind of cylindrical piece of metal that go onto a shaft and kind of lock it into place. So which shaft collar do we use? That's a very good question. We go into back into WCP, we go into hardware and tools, go into clamping shaft collars. We use the WCP 0800, this one right here. So you do the kind of the same thing here as you did with gears. You go into the table here, copy any of these links. So copy link address, go back into your gearbox practice, insert other documents, home. Then you paste the URL, click on the document, and find what you can do here is you can quite literally search up WCP-0800, enter, and this thing comes up, press on it, and it should appear, and there you go. That is the clamping shaft collar we use, but we do put an 1/8 inch spacer in front of between the shaft collar and the bearing. Because if we just attach the shaft collar if we just make the shaft collar touch the bearing without a spacer in between, like this, we look from a side view, it's very close over here, all right, which is not really, I'll say it's kind of sketch. Um, Also we did that last year, so I'm just kind of following suit. Put an 1/8 inch spacer connected to this bearing right here, this face. There you go, check mark. And now you can connect this um the shaft collar to the spacer like that, and press check mark, and there you go. Now your shaft won't move anywhere. So this should be the final result. Um, Now you're probably wondering, wait, how does this gear not just move out this way? Well, this part of the spline access is threaded, and we also have spacers for spline access. The reason why I don't really want to put it in right now, we can figure out the spacing, like when we're manufacturing it really easily. Okay, so one last demonstration. This is going to be for the rounded spacers and what I mean by what these spacers do. Um, so I am just going to import a lock nut, this lock nut from MKCAD. And let's just say that we want the bolt to go through, oh, 90. We want the bolt to go through right, the head of the screw should end right here. So the lock nut will be right there, and I will insert a standard contact. I will make it 1.5 inches in length. And there you go. This, cool. So if you make the spacer transparent, you'll see that the bolt is going through the spacer, and it's basically just kind of, locking everything in place. The reason why we use a spacer is because if we do not use a spacer and just use the bolt and the nut, the bolt and the nut compress inwards, right? So there's nothing stopping it from just fully compressing the gearbox together. But the spacer there acts as a stopping point between the bolt and the nut, between compressing it fully. So that's what I mean by spacer. Yeah. Then if you also want to, you can go ham and like add the nuts and bolts into this assembly as well if you feel like it. But just remember that during build season, we will not be adding bolts, nuts, spacers, washers, etc. Any type of like fastener or like yeah, fasteners. Like I know these are called fasteners as well. Like in real life fasteners, like even rivets. We're not going to be adding any of those to our assembly because it really slows down our document and it's just not worth it. Okay, so nice. You have just made your first gearbox. There is also a gear relationship in Onshape if you want to play around with that. I don't think we're probably not gonna be using it during build season as well. But here it prompts you to select mates. Make sure that these two are revolutes. It's just an optional little exploration for you guys there as well. Okay, so homework now is one, this is not optional. Create another single stage gearbox. You can decide the number of teeth for your input, number of teeth for your output. Just make sure that the input is being ran by a Kraken. Okay? And then optional homework, task two, you can create a, multi-stage gearbox, like two or three if you want. And I posted in design some resources that you can use as like examples and like inspiration. So yeah, that's basically it.